Good afternoon, class. This is Pythagoras Trigonometry Practice Test Number. Module 4 covering uh, chapter 8. Application of trigonometry, polar coordinates and vectors. The second part covering 8.4. Polar equations and graphs. 8.5. The complex plane and the Morse theorem. And 8.8. Vectors. Plot the point in polar coordinates. First, reminding you that what's the polar axis? If you go to a basic rectangular coordinate system, we have x comma y. And in the case of a polar axis, we have r comma theta. X comma y becomes r comma theta. So either we have distance from the x and y coordinates. In other words, x is the distance from y is the distance from the x-axis, or r is the distance from the pole or the origin, and theta is the angle that it makes. Now, so one easy way to plot points would be to go with a bunch of circles centered at 0, 0. Then we have radius 1, radius 2, radius 3, and that would be the tick marks, okay? And so in this case, 4 pi over 6. So you're going to locate pi over 6, and then 4 tick marks. 4 tick marks, you can go to the fourth circle in essence. 1 pi over 2. Pi over 2 or 100 or 90 degrees, and 1 tick mark, only the first circle. Negative 2, 0. Well, first let's look at 2, 0. 0 means this angle, okay? The x-axis or the polar axis. So if I have positive 2, that means 1 and 2, the second circle. But because it's negative 2, it goes in the negative direction, and therefore it's located here. Okay. Now, polar can be represented infinitely many ways, because r comma theta can be r comma theta plus 2k pi, k is an integer. If you want r to be negative, then you add a pi theta plus pi plus 2k pi. Find other polar coordinates for part B1, pi over 2. Well, if you want r to be positive and this to be negative, just add negative 2 pi or subtract 2 pi. So from pi over 2, I can subtract multiples of 2 pi, 2k pi. That's what we are doing. It happened to be negative. And so that gives us 1 of negative 3 pi. Now we want r to be negative. So we go back to this one and we say we are going to add. This means odd multiples of pi, 2k plus 1. Just add pi, but make this negative. So negative 1. Pi over 2 and pi is 3 pi. We want to keep r positive. That means we want the same number 1. But between 2 pi and 4 pi, just add 2 pi to pi over 2. And that gives you 1 comma 5 pi over 2. This was just to get you started with how we plot pairs. Plot the points first, then find their coordinates. And in this case, the Cartesian or rectangular coordinate given. We are interested to find where the polar coordinate 6 comma 150 is given. So 150 degrees. So we start from here, we go 150 degrees. So you can see the angles, 15, 30, whatever. And you have 150 degrees. So that would be the direction we are moving on. Number 6, we go with 6 tick marks. More specifically, we go with 6 circles, the first one being this one, 2, 3, 4, 5, 6. That's how you play. Okay, so for polar coordinate. And now, polar has coordinates r comma theta, rectangular has coordinates x comma y, x is r cosine theta, y is r sine theta. Let's plug in. So we get r cosine theta, or 6 cosine of 150 degrees. 150 degrees, that means 30 degrees is the reference arc. That means the same as cosine of 30 degrees, which is square root of 3 over 2. However, cosine is negative in the second quadrant, so minus square root of 3 over 2. And we get negative 3 square root of 3. Let's do the sine. Y equals r sine theta. Again, 150 degrees, the same as 30 degrees, and sine is positive in the second quadrant, makes it 1/2, and the answer is 6 times 1/2 equals 3. Therefore, 6 comma 150 degrees is the same as negative 3 square root of 3 comma 3. What about 2 comma negative 2? Let's go 2 to the right and 2 down, because we have really both in essence the rectangular coordinate system and a polar grid. So 2 to the right, 2 down, 2 negative 2. And let me erase my work. The relationship between the two is such that x squared plus y squared is r squared, and tan theta is y over x, and adjust for quadrant as always. Therefore, we're going to start with x squared plus y squared, and that is 2 squared plus negative 2 quantity squared. This is 4, becomes 8. And r is square root of 8. Square root of 8 is 2 square root of 2, because eight is 4 times 2. What about the angle? Y over x, which makes it minus 2 over 2, which makes it minus 1, and theta is minus pi over 4. So we write r is 2 square root of 2, theta is minus pi over 4, and therefore the pair 2 comma negative 2 is the same as 2 square root of 2 minus pi over 4. If you want this to be positive, you add 2 pi and you get 7 pi over 4, and that's just as good. Transform the polar equation r cosine theta equals negative 2 to an equation in rectangular coordinates and graph. R cosine theta equals minus 2, and x is r cosine theta. That means x equals minus 2, and it is a vertical line. X equals minus 2. R equals 2 cosine theta, and we want to transform the polar equation to an equation in rectangular coordinate. And we want to graph it. So r cosine theta, we're going to write x equals r cosine theta, r squared is x squared plus y squared, and r is 2 cosine theta. This is what's given. As you may recall, the technique is to multiply both sides by r. When we do that, this becomes r squared, and the right side is 2r cosine theta. So r cosine theta is x, therefore this is 2x, and x squared plus y squared is r squared. We are going to bring everything to the same side. And for this one, b is -2. Divide by 2 is -1. Square root is +1. We are completing the square, everybody. And so the left side is x minus 1 squared plus y squared equals 1. It is a circle centered at, reminding everybody, x squared plus y squared equals r squared centered at 0, 0. X minus h quantity squared plus y minus k quantity squared equals r squared centered at h, comma k. Therefore, this is a circle centered at 1, comma 0 with the radius square root of 1, which is 1. So, since this is too small, we're going to go with 2 tick marks being 1. So circle 1, say this one, okay, this one, and now we draw the circle, okay. We want to transform the polar equation r cosecant theta equals 8. In the same manner, we are going to rewrite this as cosecant is 1 over sine. So r over sine theta equals 8. Cross product r gives us r equals 8 sine theta. The technique, the same thing, multiply both sides by r. Whenever you have r equals something times sine or cosine, that's the technique. And this becomes r squared equals 8 r sine theta. R squared is x squared plus y squared, and this is y. Therefore, we're going to replace it as x squared plus y squared equals 8y. We're going to move the 8y to the right, to the left, and set it next to y squared. B is -8. Divided by 2, -4. Square it. Positive 16. We add 16. So the left side becomes x squared plus y minus 4 quantity squared equals 60. Which means this is a circle, according to this, centered at 0, 4. The radius is square root of 16, which is 4. So 0, 4. 1, 2, 3. In this one tick mark is 1, and then you draw a circle. Identify, graph the equation, and convert to a rectangular equation. R equals a number. You may remember it represents a circle. Square both sides, you get r squared equals 16. So when r equals 4, x squared plus y squared equals 16, which is a circle centered at 0, 0, with the radius being square root of 16 or 4. So r equals 4 is a more simplified version of representing the same equation, the same graph. So circle, center at the pole or the origin, the radius is 4, this one, and that's the theta equals 3 pi over 4. We want to take the tangent of both sides because when theta is a number, it represents a line that goes through the origin. So if you take the tangent, we know tangent of 3 pi over 4 is -1. So tan theta equals -1 on the one hand. On the other hand, it's equal to y over x. The cross product says y must be equal to negative x, which means a line through the origin, okay, that goes in the second to the second and fourth quadrant. When y is positive x, goes to the through the first and third quadrant. R sine theta is -3, R cosine theta is +4. The two equations, we want to find them, and you may recognize them as a line because y equals R sine theta. That means R sine theta equals -3 and y equals -3. This makes it a horizontal line. So you locate 0, -3 as far as the rectangular coordinate system is concerned, and you draw a horizontal line. Our cosine theta equals 4, that's x. So x equals 4 is a vertical line. You locate 4, 0 as a point, and you draw a vertical line. Which means the synopsis of what we covered, the theorem says if R is a number, is a fixed number, any number, it's a circle. The center is at the pole and the radius is A. If theta equals alpha, then we have a line such that y equals tan alpha times x. Horizontal line HL for short, R sine theta equals a constant, it becomes y equals A. If it's R cosine theta equals A, that's a vertical line, x equals A. Any of these will result in a circle. If you have R equals plus minus 2A cosine theta or plus minus 2A sine theta, the radius for each case, each and every one of them, is A. The difference is the center. When you have cosine involved, the center is along the x-axis or the polar axis. If it's involving sine, it's along the y-axis or pi over 2. Theta equals pi over 2, 90 degrees. Okay, 2a gives you 0a, minus 2a gives you 0 minus a, or so on and so on. Symmetry in polar coordinates. Symmetry with respect to WRT, the polar axis or the x-axis. If in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. Theta minus theta, okay. R is identical. Symmetry with respect to the line theta equals pi over 2 the y-axis. If in the polar equation r comma theta can be replaced by r comma pi minus theta, the graph is symmetric with respect to the line theta equals pi over 2, like so. R comma theta, r comma pi minus. And symmetric with respect to the pole or the origin. If in the polar equation r comma theta can be replaced by negative r comma theta or r comma theta plus pi. You have to check both of them. The graph is symmetric with respect to the pole, or if it's symmetric with respect, these two ends up being symmetric with respect to the pole or the origin. So r comma theta, if you add pi to it, okay, or you make it minus r. You want to graph R equals 1 minus cosine theta, and in short, you just plot a bunch of pairs R comma theta, and you go with the easy arcs that you don't have to look them up, reminding you that R equals A times 1 plus minus cosine theta, or A times 1 plus minus sine theta if A is positive, passes through the pole, and it's a cardioid. But in any event, so theta R is 1 minus cosine theta, and the pair is R theta. So we are going to look at easy numbers from 0 to pi. 0, cosine is 1. 1 minus 1 is 0. Pi over 6, 1 minus, this is square root of 3 over 2. Pi over 4, 1 minus square root of 2 over 2. Pi over 3, 1 minus 1 half, or 1 half. Pi over 2, 1 minus 0, or 1. 2 pi over 3 is the same as pi over 3, but negative. 1 minus negative 1 half. 1 minus negative 1 half, which makes it 3 halves. Pi, 1 minus cosine pi. Cosine pi is negative. With this negative becomes positive 1. They add up to 2. So I hope you find this easy. Okay. Now again, we're going to go with 2 tick marks. And 0, 0, of course, is the pole. Class, when R is 0, doesn't matter what angle, any angle. When R is 0, it's the pole. Now, 1 half pi over 3, because 2 tick marks represent 1, 1 tick mark represents 1. So find pi over 3 and just 1 tick mark. That means 1 circle. Okay, the first circle, roughly. 1 pi over 2, again, 2 tick marks means 1. That means you're looking for 2, the second one. So pi over 2 is this one, and 1 would be 2 circles. Again, you might say, okay, why we are not going with those? For example, square root of 2 over 2, 1.4 divided by 2 is about 0.7. 1 minus that, it's 0.3. I want to go with the easy numbers. 3 halves and 2 pi over 3. So that means 3 tick marks, the third circle, 2 pi over 3 located, and go with the third circle. Okay, 1 and 2 and 3. 2 and pi. Okay, 2 and pi. We are going to go with the fourth circle, and pi is this one. Okay, 1, 2, 3, 4. Just to give you an idea. So it looks something like that, half of it. If we replace the theta with negative theta, nothing changes because cosine is an even function. And therefore, if minus theta and theta result in the same thing, what do we have? Symmetry with respect to the polar axis or the x-axis. If in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So in short, just if I want to follow that, so this is 1, and then by symmetry, I have that graph. Let me actually draw it and then erase it. So it will look something like this, just by symmetry. Or you can plot those pairs. I hope you see that. For example, 4 pi over 3 is the same as 2 pi over 3. Okay? 3 pi over 2, cosine is 0, so it's 1, and so on and so forth. And that's the entire graph. Plot the complex number 1 plus I in the complex plane and write it in polar form, write theta in degrees. So here's the grid. This is the real axis, the x-axis. Here's the imaginary axis, the y-axis. And reminding you, z equals x plus yi. That's the same as a plus bi we have been dealing with. The shorthand notation is r cis theta. That means r times cosine theta plus I sine theta. As always, r squared is x squared plus y squared. The magnitude of z, or r is squared of x squared plus y squared, and tan theta is y over x. And you always pay attention to the quadrant, and I can't emphasize this enough, okay? So you go one to the right, one up, and we're going to go perhaps with two tick marks being one, because again, this is small. So two to the right, two up, two tick marks representing one, okay? First, I want you to notice that. Now, if you look at this one, everybody, okay, this is r, this is theta, z is x plus I, y, and this is equals z bar or z star. It's x minus I, y. It's the complex conjugate of this one, okay? Everybody remembers the conjugate of a plus b is a minus b. So this is the real one. This is the imaginary line, okay? So connect them. And as we said, r is square root of x squared plus y squared. So 1 squared plus, this is 1i, 1 squared becomes square root of 2. And tan theta is y over x, or 1 over 1, or theta becomes 45 degrees. So that means this angle is 45 degrees. And so z, which is 1 plus I, is r cis theta. So replace the theta with 45 degrees, and you're done. Shorthand notation class, you can leave it like that, of course. Or you can say square root of 2 cis 45 degrees. If they wanted in radian, you would say pi over 4. So I mean, you want to pay attention to that, because some questions they ask for degrees, some do for radians, and so you want to answer it accordingly. All right, we want to write the complex number 4, parentheses cosine 7 pi over 4 plus I sine 7 pi over 4 in rectangular form, and plot the complex number. Well, 7 pi over 4 the reference arc is pi over 4. So cosine and sine are both square root of 2 over 2. In the fourth quadrant, cosine is positive, sine is negative. So 2 square root of 2 minus 2 square root of 2i. So theta, you go 7 pi over 4 and locate. So 2 square root of 2 to the right, 2 square root of 2 down, and you locate the tip. In this case, that would be a complex number, 4 cosine of 7 pi over 4 plus I sine of 7 pi over 4. That's the point. We want to find z times w and z over w, and leave the answer in polar format where z and w are given. And I want to remind you that when we want to multiply and divide polar numbers, the product z1, z2 is r1, r2. Cis theta 1 plus theta 2, add up their arguments. If you're dividing r1 over r2, cis theta 1 minus theta 2. And therefore, if I want to multiply these two numbers, I'm going to multiply 2 by 2, and then I'm going to add power 8 and power 10, and I'm going to write 2 times 2 cosine of power 8 plus power 10 plus I sine of power 8 plus power 10 according to this formula. And I get 4 cosine of 9 pi over 40 plus I sine of 9 pi over 40. I hope everybody is okay with adding these two, noticing that 40 is the LCD. If you want to divide, obviously the 2's cancel out. So you put cosine of power 8 minus power 10 plus I sine of power 8 minus power 10, or RC theta, as I mentioned. And of course, this becomes power 40. Let me just use a different color. 4 divided by 8 is 5, so 5 pi. 4 divided by 10 is 4, so 4 pi. That's how you get. You're adding just a couple of fractions. It's not a big deal. Write in the standard form a plus bi, where we are interested in finding square root of 2 cis 5 pi over 18 to the power of 6. So I'm going to remind you of everything that we have done, and I'm going to add the De Moivre's theorem. The De Moivre's theorem says if n is larger than or equal to 1, z equals r c theta. You want to raise it to the power of n. You raise r to the power of n, and then you multiply the theta by n. So with that being the case, we are going to raise this to the power of 6, and we're going to multiply this by 6. Now, square root of 3 to the power of 6 is 3 cubed. 6 cancels out the 18. 6 goes away. This becomes 3. So we have 5 pi over 3. 3 cubed is 27. 5 pi over 3. In the fourth quadrant, cosine is positive, is the same as cosine of pi over 3, but sine is negative. So we change the plus to minus. Okay, everyone? This is 1/2, and this is square root of 3 over 2. So 27 times 1/2 minus square root of 3 over 2i. We multiply the 27, we get 27 halves minus 27 square root of 3 over 2i. Given z equals 1 plus I, let's find z to the power of 10. We're going to use the De Moivre's theorem. The first thing is to find z, but we did it in question number 9, and we found it to be square root of 2 cosine cis 45 degrees, or cosine of 45 degrees plus I sine of 45 degrees. Therefore, z to the power of 10, we raise this one to the power of 10, we multiply the argument by 10. Square root of 2 to the power of 10, that means 2 to the power of 5. And this is, of course, 450 degrees. 2 to the power of 5 is 32. And 450, if we subtract 360, we get the same thing. So we put it into the first complete revolution by taking out multiples of 360 degrees. In this case, one of those 360 degrees becomes 90 degrees. As you know, cosine of 90 degrees is 0. Sine of 90 degrees is 1. And we get 32i. And I hope you realize the importance of knowing De Moivre's theorem, because Otherwise, raising this to the power of 10 takes forever, okay? So it makes it really nice and easy. Given z equals 8, find all complex cube roots. So we have all of this, and we are going to add the roots. If w is r, cis theta sub 0. For n larger than or equal to 2, there are n distinct complex nth root of w. So you take the nth root of r, cis theta sub 0 over n plus 2k pi over n, and you use k to be 0, 1, 2, all the way to n minus 1. Again, 2k pi over n or 360 degrees times k over n means the same thing, okay? Sometimes you want it in degrees, sometimes in radians, and sometimes one is easier than the other. All right. 8 is 8 cis 0, okay? Or just cis 0 without, putting the degrees. This is in radians if you put it in this form. Now, in general, if you have a complex number which has a real part only, it's always that number. If z is any number, let's say k, then it's the same as that number k cis 0. But if it's, let's say, minus k, then it's k cis pi or 180 degrees, okay? Just, you can verify that. If you plug in here, this is 1, remember this is 0, you get what? 8. And so we want the root, we write it in this fashion. Let me erase my work. And so we want cube root, okay? So we want the third root of r, which is 8, cis, and theta sub 0 is 0 degrees, or 0 radians, divided by n, 2k pi over 3. If we're going to go with radians, we're going to go with this one. Remember, this doesn't have a degree, means radians. And of course, basically, this goes away. Cube root of 8 becomes 2, and it's 2 cis 2k pi over 3, 2k pi over 3, k is 0, 1, 2. We plug in 0, we plug in 1, we plug in 2. So z sub 0 is 2 cis 0, z1 is 2 cis 2 pi over 3, and z2 is 2 cis 4 pi over 3, right? So you're replacing the k with 0 becomes 0, with 1 becomes 2 pi over 3, with 2 becomes 4 pi over 3. 0, you get 2. 2 pi over 3, we're talking about the same as pi over 3 as a reference arc. In the second quadrant, cosine is negative, sine is positive. You multiply by 2, you get minus 1 plus I squared of 3. For 4 pi over 3, now both of them are like pi over 3, but negative. So this is a different. This is the same negative 1/2 you had. Now this is minus square root of 3 over 2, because in the third quadrant, both sine and cosine are negative. So z equals 8 has 3 cube roots. Z sub 0 equals 2, z1 equals negative 1 plus I squared of 3, z sub 2 equals minus 1 minus I squared of 3. In fact, raise this to the power of 2, obviously you see 8. You can try this one and this one. If you raise it to the power of 3, must give you also the same number, namely 8. Let's switch gears and look at vectors. Vector V has initial point P3, 2 and terminal point Q. Write Q is 5 comma 6. Write V in forms of AI plus BJ. Find its position vector. Also find its magnitude. Let's discuss a couple of things. Let's remind everybody of what a vector looks like. First, understand that this is the initial point, this is the terminal point, initial point, terminal point, and two vectors are identical or equal if they have the same direction and the same magnitude. It doesn't matter where you start them. But if you start them at the origin, the initial point is called the position vector. So position vector V, if V which has components AB is an algebraic vector whose initial point is at the origin, then V is called a position vector. Algebraic vectors, V equals AI plus BJ or A comma B, A and B are called components of the vector V. So a vector with initial and terminal points, initial is x sub 1, y sub 1, and terminal is x sub 2, y sub 2, is equal to the position vector PQ such that we have x sub 2 minus x sub 1. This one is x sub 2 minus x sub 1 equal to A, and y sub 2 minus y1 equals B. That's the idea. Therefore, if we want to come up with the answer here, we're going to say 5 minus 3, 6 minus 2. And obviously, we get 2 and 4. Or we can say 5 minus 3i plus 6 minus 2j is 2i plus 4j. Also reminding everyone the magnitude of a vector is square root of a squared plus b squared. The magnitude must be 0 or positive. The magnitude is 0, that means the vector is 0, it's a 0 vector. The magnitude of two vectors that are opposite are the same, minus v and v have the same, and if you have a times v, you can take the a out in an absolute value sense, and therefore, in this case, we're going to go with a squared plus b squared, which means we're going to go with 2 squared plus 4 squared. This is 4. This is 16. They add up to 20. Four times 5. 4 comes out as 2. And we are done. Given v is negative 2i plus 3j and w is 5i minus 4j, find the magnitude of v plus w, 2v minus 3w. But the magnitude of v, we just follow square root of a squared plus b squared. We're going to square negative 2, we're going to square 3, and we're going to add them up. This is 4, this is 9. And we get square root of 13. V plus W, just add them up component by component, meaning these two add up to 3i, these two add up to negative j. Two v minus 3w. So you're going to put the v and multiply it by 2. You're going to put the w and multiply it by negative 3, and you just distribute. You get minus 4i plus 6j. You get minus 15i plus 12j. And again, components, these two add up to negative 19i. These two add up to 18j, and we're done. And reminding you that the idea of adding two vectors, if I want to add u and v, the terminal point of view and the initial point of view are connected. Now the initial point of view, okay, to terminal point of V gives you U plus V. And if you continue with W, the initial point of U and the terminal point of W. That's how you do the adding using parallelogram format or triangular format. Find the magnitude, direction, angle, and a unit vector in the same direction for the vector v equals 3i plus 3j. Magnitude, square root of a squared plus b squared. So it's 3 squared plus 3 squared, which is 9 and 9, 18. And square root of 18 is 3 square root of 2 because this is 9 times 2, 9 comes out as 3. So that's how you find the magnitude. As far as the direction is concerned, reminding everyone, here's the vector, and here's the alpha, the direction. Vector equals its magnitude times cosine alpha I plus sine alpha j. Direction angle alpha is between 0 and 360 degrees. It's between the vector and the I, meaning the positive side of the x. So let's find this angle in this case, following that tan of alpha is b over a, or in this case 3 over 3. It makes it, obviously, as you can see, the first quadrant, and alpha is tan inverse of 145 degrees or pi over 4. So if that is the case, we are going to write it in this format. We have the magnitude and we have the alpha. And this is the way they want it. If you calculate cosine of 45 degrees, sine of 45 degrees, and multiply them, you get the same thing back. I want you to know that. But that's how they want you to represent that now. Unit vector. Unit vector means you're looking for a vector with the same direction, but the magnitude must be 1. In other words, unit vector in the direction of v is the unit vector is the same vector divided by the magnitude. So this one divided by 3 square root of 2. Along the x-axis, this is the unit vector along the x-axis, okay, 1, 0. This is the unit vector along the j-axis, the y-axis, 0, 1. And so we have ai plus bj. And so we are going to divide this one by the magnitude we found. So we have 1 over square root of 2, and I hope you recognize it as square root of 2 over 2 because you can multiply the top and the bottom by square root of 2. So square root of 2 over 2i plus square root of 2 over 2j, and if you have any doubts, square this number, you add them up, must become 1. That's how you know it's a unit circle. Write the vector v in the form of ai plus bj, given its magnitude and the angle a alpha or a it makes with the positive x-axis. Also find a unit vector in the same direction for the vector and check its magnitude to be 1. The magnitude is given as 14, a is given as 120 degrees, And this is the formula we're going to plug in. This is 14, this is 120 degrees. 120 degrees. For 120 degrees, the reference arc, or alpha of R, let me just erase that. Is 60 degrees. So they both are like trigonometric functions of 60 degrees. In the second quadrant, cosine is negative. So cosine of 60 degrees is 1/2, but cosine of 120 is negative 1/2. And this is positive because sine in the second quadrant is positive, square root of 3/2. So you multiply by 14. The denominator goes away. This becomes minus 7i, and this becomes 7 square root of 3j. How do you find the unit vector? We are going to divide this by its magnitude 14. So this divided by this is negative 1/2. This divided by this is square root of 3/2. So we have negative 1/2 I plus square root of 3/2j. We are done. You can check by raising this to the power of 2, raising this to the power of 2. You get 1/4 and 3/4 equals 1. That's good enough, or square root of 1 is 1. This is not a bad idea to check. You don't have to, but you know. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. And again, reminding you of all those stuff. So a plane is doing 200 miles per hour. That's the magnitude. North 55 degrees east is this way. So this is north 55 degrees east. First of all, because we need the angle that it makes with the positive side of the x. If this is 55, everybody, this is 90 minus that, or 35 degrees. So this becomes 35 degrees. So how do we represent this? We write, if this is v sub a, we write its magnitude as 200 miles per hour, and alpha is 35 degrees. So we write velocity relative to air, 200 miles per hour. Theta sub a is this blue one, 90 minus 55, or 35 degrees. What about the wind? The wind is blowing from west to east, which makes the magnitude 35 miles per hour. And the angle, because it's parallel to the x-axis, this is parallel, therefore the angle is 0. So velocity of the wind is the magnitude is 35 miles per hour, and the angle is 0 degrees because it's going from west to east, right? Parallel. So we wrote what's given. So what do we want to approximate? Approximate the ground speed of the plane to the nearest miles per hour and the true course of the plane. In other words, now we really have to add those two. So when we connect the initial point to the terminal point here, this will give us what we are looking for. We can find this alpha. We're going to go through that by, in other words, we're going to add these two to get this one. That would be what we are looking for here. So we can find its magnitude. We can find alpha, And to find the true course, we need, if this is alpha, we need this angle, which is 90 minus that. So the ground speed is the magnitude, miles per hour. And the true course, it's northeast, northeast. What's the angle in between? 90 minus alpha. So north, 90 minus alpha, east. So I hope it's clear to everybody. All right, so we are going to add these two up. In order to add them up, we're going to write them component-wise using V is magnitude times cosine alpha I plus sine alpha j. We're going to write the first one. 200 cosine of 35 degrees I plus sine of 35 degrees j. You have to use a calculator because 35 degrees is not a common arc. And you get those answers. We're going to do the same thing for the wind. And that we don't need a calculator because cosine of 0 is 1, sine of 0 is 0, so it's simply 35i. So the speed with respect to ground, basically add the two VA and VW, which means you are going to add their components. These two get added, and this doesn't have anything to be added. This is unchanged. These two add up, and we get 198.83I plus 114, this doesn't change, 0.72J. And so to find the velocity with respect to the ground speed, we want the magnitude, which is a squared plus b squared. And that means 198.83 squared plus 114.72 squared under the radical, everybody. You put it into a calculator, and it gives you about 230 miles per hour. Tan of alpha is b over a, so tan of alpha is b, 114.72, over a, 198.83, which makes alpha tan inverse of this number. You put it into a calculator, and you get roughly 30 degrees. So we go back here, and we say we are doing 230 miles per hour, north 90 minus 30. That means north 60 degrees east.